Lesson 8.4, related rates. One formula again, but this time with cones and cylinders. So remember, a cone is like, think of it upside down like an ice cream cone, and then whereas a cylinder has two circular bases, like a can. Okay? The radius of a cone is decreasing at a constant rate of 5 inches per minute. The volume is decreasing at a rate of 249 cubic inches per minute. At the instant, when the radius of the cone is 2 inches, the volume is 51 cubic inches. What is the rate of change of the height? And they're nice to us and give us the formula for the volume of a cone again. So if it helps you draw a picture, if not, it doesn't matter. Let's pick this apart. We've got a radius changing at a rate. So that's going to be dr to dt. And it's decreasing at 5 inches per minute. The volume is decreasing at a rate. So that tells us dv to dt of 249 cubic inches per minute. At the instant, when the radius is 2, so radius is 2 inches and the volume is 51 inches, what is the rate of change of the height? So we're finding dh to time. Okay, so let's just start by taking the derivative of the volume. Okay, would be the easiest here to maybe actually separate this and just pull this out as a constant and then just do product rule. Here might be our best bet. So we got dv to dt. That's like pi over 3, right? Because 1 times pi is pi, pi over 3. So pull that out in front. Times, keep r squared, times the derivative of h, which would be dh to dt, plus, keep h, times the derivative of r squared will be 2r times dr to dt. All right, what do I have? I have something to plug in here. That'd be negative 249 pi over 3 times the radius I know. They told me specifically when it's 2. Just get squared times dh over dt is what I'm trying to find. So that should be my only unknown. I ran out of room again. Plus 2 times h times r. That's what I don't know. I don't know what h is. And so I'm going to have to go back to my formula of volume to figure that out. So volume specifically is going to be when it's 51. 1/3 times pi times the radius squared times h. That's 4 times 1/3 would be 4/3. Oh my goodness. 4/3 pi times h. So I'm going to take 51 times 3/4, which is 0.75, and then divide by pi. 12.175. Okay, where was I? So that'd be 2 times 12.175 times the radius is 2 times dr over dt. They told me it was -5. Okay, so sorry for the mess. Let's see if we can clean this up. So we'll have negative 249 equals pi over 3 times 4 dh over dt. 2 times, oh, I cleared it out again, 12.175. Try not to do that. Times 2 times -5 is negative 243.5. I'm going to go ahead and get rid of this pi over 3. I'll take times 3 over pi. So I'm going to take negative 249 times 3 divided by pi. Okay, I'll add 243.5 to that. And then divide by 4. So I get that the height is changing with respect to time is 1.431. You might have something slightly different if you kept the full decimal in there. And that would be inches per minute. Okay, number 2. This time it's the height of a cylinder. Let's just go ahead and pick it apart while we read. The height of a cylinder is decreasing at a rate. So dH to dt is losing 3 feet per minute. The volume remains at a constant 17 cubic feet. That's kind of weird. The volume stays the same, but the height is going to shrink. Must be getting wider. At the instant when the radius is 1 foot, what is the rate of change of the radius? Volume of a cylinder is pi r squared times h, because volume is saying, okay, what's the area of the base? That's a circle, pi r squared, and then that many circular slices all the way up its height. Okay, let's just go ahead and start differentiating. We got dv to dt. That would be what? So again, I could take out the pi if you'd rather and do this. And then do your product rule. That would be keep r squared times derivative of h plus keep h with derivative of r squared would be 2r times dr to dt. Okay, I don't have a volume to time, but I know the volume is staying a constant. So if something's staying a constant, what is its rate of change over time? So if I were to differentiate that, you should be able to tell me that if it's a constant, it's not changing at all. A constant, when you differentiate it, becomes 0. So this actually is going to be 0 equals pi. The radius, they said, was 1. So that'd be just times 1. Times dh over dt, which was -3. Plus 2 times, do we have a height? No. Okay, so I've got to find that. Okay, volume was 17 pi, radius is 1 squared times h, that's 1, so that's pi. So 17 divided by pi is what h is going to be. I'm not going to clear that out this time. And then radius is 1. And then dr over dt is what we're trying to find. Okay. So that would be -3. We got 2 times this 10.823-ish. Times dr over dt. And this is all times pi, but I'm going to divide pi. 0 divided by anything is 0. I'm going to add 3. And I'm going to divide by 10.823. Should be very small. So the radius is changing with respect to time is 0.277 feet per minute. So the radius is getting bigger to keep the volume the same.